Spring, 1980. Mount St. Helens is one of the major peaks in the Cascade Mountains. Within 10 seconds, the volcano's northern flank collapses in the largest landslide in recorded history. It releases millions of tons of magma in a colossal explosion.
Hey guys, I'm coming to you from the crater at Mount St. Helens, and this place is astounding. It's really amazing. We're only like 3 hours from Seattle, and we have these giant glaciers coming down from this caldera at the bottom, a steaming river with hot springs coming up. This is world class. What better place in the world is there to talk about Google search? Before we talk about Google search, let me just give you kind of a brief introduction to Google as an entity. Google is huge. It's got apps, it's got ads, it's got the search engine, it's got the Google Docs, it's got Gmail, it's now got Google+. It's a world, it's a whole entire world of applications, and we'll talk a little bit more about the strategy behind being a world of applications later. But right now let's focus in on search. And search, the Google search, which we'll think of not as the whole of Google, but just Google search on its own. The Google search we're going to focus on, and it consists of indexing, where Google goes out and finds the right information or finds as much of the information on the web as it can. Querying, where you ask a question against that information that Google has found. And storage and retrieval, where Google brings back results to you and gives you back what it thinks is the best answers to your question. So we're going to talk in detail about each one of those. But before we do, let me just give you this idea that Google's a web system just like any other web system. If you remember, we talked about web systems consisting of 3 tiers. A presentation tier, a processing tier, and a data tier. Google is no different. Google search is no different than that, no different than Facebook in that sense. It has the stuff that goes on in your browser that is showing you a page that's created in HTML. It has a server that's creating that page, that's rendering that page, that's putting everything on that page and sending it to the browser for display. It's got a bunch of servers and a bunch of computers that are doing processing, that are making sense out of what you ask Google and going and searching and doing all that kind of stuff. And then it has a giant data store behind the scenes that in fact is storing a copy of everything that Google has indexed on the web. So Google is no different than any other web application in that sense. Of course, what it does is very specific. It's very different than Facebook. It's very different than World of Warcraft. It has its own particular features, but really the fundamental architecture of Google is the same, with a presentation layer, a presentation layer that includes what goes on in your browser, as well as the server, which is formatting pages, a processing layer that is all the logic, does all the things that Google needs to do to make its functions work, and a data layer that stores all the Google information. In fact, stores all the pages that it has indexed on the web. So Google's just like any other web system. Let's take a little bit of a closer look at the Google search architecture, just long enough to realize that we don't want to talk about the Google search architecture. It's way beyond our means to even unpack it. If you look at this diagram, you'll see that it's pretty complicated. The interesting thing about this diagram is not trying to unpack it and figure out exactly how Google works. We're not really going to go into that level of detail. The interesting thing is to see that this was one of the original diagrams that was made by Larry Page and Sergey Brin to invent Google in the first place. They were just a couple of students at Stanford. They figured out a new way to do basically what we'll talk about later, page ranking. And from that, they built an empire. It's amazing. That happens, more often than you'd like to imagine on the web, that a couple of guys or a guy and a girl or somebody comes up with an idea and away they go. So that's something to understand, that the Google search architecture was really the fundamental intellectual property, the fundamental thing that started Google as an empire, and it was created by these 2 guys that just kind of came up with it. They were computer scientists. Okay, the other thing to understand, and I've said this before and I'll say it again, Google is massive. Google is enormous. Google is in terms of the amount of information stored, is just astounding, mind-blowing how much information is stored in data centers all around the world. Another thing that I want to point you to actually is this picture, which is a zoom in. On a previous slide, I think, on a previous slide I gave you the URL to get to this picture. we're going to be using this picture and zooming in on different parts of it. It's a nice illustration of the overall way that search works on Google, and as we go through these lectures, I'll zoom in on different parts of it. Okay, so let's talk about the way Google search works. And we're going to break it into three parts: indexing, querying, and storage and retrieval. Right now we're going to be on indexing. So first of all, I have to give you this concept of what is an index. What is an index? Why is an index an important thing for Google to search? So let me start with the general concept of an index, and then we're going to go down into details about the particular Google type of index. So an index in general. You've seen indexes, right? Turn to the back of any book and you'll see an index. What's the index in the back of the book? The index in the back of the book is a set of phrases, terms we call them, terms in the index. And each of those terms or phrases is, it has different page numbers next to it, right? So it'll say Google, page 43, 96, 123, 280, 282. So that's a book index. It's an alphabetical list of terms with page numbers after it. Right? So you got that? That's just commonplace. But I want you to keep that in mind because it's a really good way to understand indexes. And as we go further and further with indexes, you'll see that they get less and less usual, less and less what you've heard of before, but they'll never lose that fundamental idea of a set of alphabetical terms and where those terms can be found, what that term describes. Okay, so that's a book index. We saw earlier in the course this idea of an index, which is on the right-hand side here of the slide, that we called a tag cloud before, and that tag cloud is a series of words, and each of those words, if you clicked on them, would take you to the place where that word is applied, where that word makes sense, where that word is what you'd expect to see. So if I click on strategy, I would expect to see all the places where strategy is discussed, where strategy is defined, where strategy is the main subject. Okay, notice how that's very different presentation than the book index, but actually doing exactly the same thing. We have a set of phrases. In this case, they're not alphabetical. They're organized kind of in an interesting configuration, but it's serving really the same purpose. And when you click on any one of those, you'll go to the places where it's mentioned. You'll go to the important places that it has to do with. The third one is a drop-down list of what's called here categories. And notice that once again, they're alphabetized. And when you click on one of those, you would expect to be talking about, specifying, saying, I want information about the term that you clicked on. So in each of these three cases that I showed here, we have a set of phrases, a set of words, and those words or phrases link you to the place that has more description. Okay, so those are some examples. Let me now give you a definition of an index. In all cases, an index really has two things: an alphabetical or numerical list, and notwithstanding the fact that one of them I showed you before isn't alphabetical in the vast majority of cases, and for us we're going to say that they're alphabetical. So they're an alphabetical or numerical. It can be like a date index where it has date in some kind of numerical order, and you click on the date and you go to things that are from that date. An alphabetical or numerical list with links back to information that's described by that term. So that applies to the book index, that applies to any web index that we'll see, and in fact, as you'll see in a minute, it's going to also apply to the Google type of index. So that's an index. It's an alphabetical or numerically sorted list in alphabetical or numerical order with links, with pointers, with something that takes you to the places in the information that are described by that word or phrase. Okay, that's the idea of an index. All right, now let's go specifically to the Google type of index. Can you get the idea just in general that suppose Google was a person and you ask Google to say, hey, tell me all the places where arachnids are mentioned. And it would go into its index and it would look under the A's for arachnids, and it would have all the pointers to all the places, and in this case they're not page numbers obviously, they're web pages, they're links to web pages. Right? So you can see how that's a logical way for Google to go about doing what it does, to have a giant index of all the words on the web and how they all and where they all are located, so that when you ask it about a particular word, it can take you to those different places. It can put up links to all those different places. Of course, we're going to see that it's far more sophisticated than that and far more complex than that, but the basic idea really holds. That is the general idea. It's got an index just like the index in the back of the book. And that index that Google has is going to allow it to answer your questions about, I want information on X on the web. All right, now let's look more specifically. You know from using Google that you can search for any word on any page on the web. Now that's not exactly true because Google doesn't index the entire web, but for the pages that are indexed by Google, you can go to any word on any page. So it has to have a pretty big index. So the way to think about how this Google index works is it takes every page that it indexes on the web, and we'll talk later about how it indexes those pages, but every page that's indexed by Google, it takes those and it puts them in a big bag, shakes them up, and shakes all the words off of those pages. But as it shakes the words off of those pages, it notes what page it came from. So all of these, you can imagine, all of these pages going into a huge bag, and Google is shaking it up really hard, and all those words are flying off the page until there's just a big pile of words. Then it pours out that big bag, that big pile full of words on the table, and starts sorting them out alphabetically until every word on every page is in order alphabetically. And then after that word comes the links, comes the pointers, comes the references to all the pages and the position on the page where that word exists. Okay, so that's the way to think about the Google index. Takes the entire page, puts it in a big bag, shakes it up with every other page on the web, all the words come flying off, pours all the words onto the table, puts them in alphabetical order, and next to each word puts a reference, a link, a pointer to where that word came from on which page. Now you can imagine the word, the would come up on a ton of pages. Google actually deals with that because nobody's really going to search for the word the, so they exclude words like that. Those are called stop words. They stop them from being in the index. They stop you from indexing them in general. Okay, so the Google type of index, as I've said, is an enormous alphabetical list of all the words on all of these pages. The Google index has lots of different names. You'll hear it called a reverse index, a full text index, an inverted index, and there are more than one that Google has. It has more than one inverted index, or sometimes also called an inverted file, or a reverse file, or a full text index. And that's usually what I'll call it because that's the most descriptive. It's a full text index. It indexes the full text of each page that it looks at on the web. And as I said, it doesn't look at all of them. Okay, so there's at least, and there's probably many more, there's at least one index for all the titles of the pages. Now, you may or may not know this, but it's the case that every page on the web has a title. Well, every page on the web is supposed to have a title. The title describes what's on the page, just like the title of a book describes what's in a book. And so for every page on the web, there's a title, and Google scripts off all of those pages, puts them in a separate bag, shakes them up, alphabetizes all the words. And why does it do that? Because the title is very important. The title is very, very indicative of what's on that page, and so it makes sense for Google to have a separate index just of the titles. And then there's also an index for the full text, all of the content that's on the page. Okay, so we have the general concept of an index, which is an alphabetical or numerical list of items of terms, and those terms are linked back to the information that they describe. Then we have specifically the Google type of index, which is Mondo. It's enormous. You can imagine how huge this index is that has every word on on all the pages that Google indexes with a set of links, a set of references to the page and the position on the page where that word is. That's the Google type of index. That's what indexing is all about. We're going to talk about indexing a little bit more later in the course, but this is the kind of index, this is the core function, the core feature behind Google is its ability to create this giant index and then do the other things we're going to talk about, allow you to ask questions about it and then give you results back based on that index. Okay, so now I'm going to zoom in on this diagram. As I told you, you can get the URL for this diagram, and it's also linked from the page on our course website that this lecture is linked to. So you can download this picture and zoom in on it yourself. But what we just talked about is this idea of a reverse index. And this is the summary, and I'll go through this summary so that I'm sure I cover all the points that are also on this diagram. Page titles are indexed, and page content is indexed. That's what I just talked about. And it also says when you search the Google index, you're not searching the actual page on the web, you're searching Google's cache, and we'll talk about that in a few minutes. Okay, so you got the idea? Google somehow, and we'll talk about this somehow in a moment, goes out onto the web, gets all of these pages, puts them all in a giant bag, shakes them up, makes this alphabetical index, preserves the link to where on the web that was, and now we have a giant index. What happens after that index? What happens in addition to that index? Well, Google has a set of editorial policies. Now, if you know anything about this idea of editorial policy, you might think of a person, who's looking over it and, changing the grammar and fixing the spelling and all that kind of stuff. That's not what they're talking about. And furthermore, there's no way that they could do something like that. There's no way that they could do anything that requires them to look at any of these pages, right? There's just way too many of them. If it's not happening automatically by a computer that does it chunk, 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 then it isn't going to happen, right? So these editorial processes are really about checking against things like, for example, checking that your page isn't on a list of pages that have been flagged as piracy or plagiarism, stuff like that. And it can do all of these things automatically. So that's Google's editorial policies. And then the other very important thing that they do is attach more information to these pages so that you can search more specifically for them. So in addition to this index, for every page on the web that they index, they're also attaching some additional information. For example, the language, the reading level, and again, they're doing this all automatically. There's some computer program that's scanning this page and determining whether it's, grammar school level, high school level, college level, PhD level, or whatever, and also detecting the language. As you probably have seen if you've ever used Google Translate, it's not that hard for a computer to automatically detect what language a page is in. So it does all that stuff automatically, and it attaches also all of that data to the pages so that it goes, for example, if you're only searching for pages in Russian, that it'll only look on Russian pages, even if there happens to be an English word on those Russian pages. Okay, so in addition to the indexing, taking all the words and making a giant alphabetical index out of them, it also attaches other information to those pages. The technical word for that other information is metadata, but I won't hold you to that term. But you may hear that term, and if you go further in information science, you'll be hearing it all the time. Metadata is a big deal to us. Okay, so we're still on this concept of what happens after the index, and now I'm going to zoom in again on this picture, and I'm going to give you an idea of what Google is saying. The search quality team and the web spam team review and refine the algorithms. This means that the team at Google is not actually looking at the pages, they're looking at the program that looks at the pages, and they're trying to improve that program more and more and more as time goes on. There are 10,000, according to this, 10,000 plus testers that are rating the quality of the results and the quality of the searches. They're not doing anything to the pages, they're just trying bizarre searches and seeing, does it work, does it make sense? Google solicits spam reports from users, so if you see a page and maybe that page is pornographic or something, or that page is a pirated page of your work, you can report it to Google. Google will put it on a list, and that page won't come back in search results. And then Google gets DMCA, that's Digital Millennium Copyright Notifications, to take down pirated work. So there's a place they go, and they find all the pages that have been declared piracy, that have been declared page plagiarism, and they won't show those either. So that's all the stuff that happens in addition to the indexing process. Okay, so far we have the general concept of an index, which is an alphabetical or numerically sorted list of terms, all pointing back to where those terms occur, what those terms describe. We have the Google type, which I said is this Mondo alphabetical index of all the words with pointers back to the web pages and the positions on the web pages where those words exist. And now we're going to talk about how does Google actually go out and get at all these pages. How do they get them? Well, imagine that you had to get to every page on the web. What would you do? If I was you, I would start from a very popular page that has a lot of links to other pages. I'd look at all the pages. I'd look at that page, that first page. Hello. I'd look at that first page, and then I'd follow all the links from that first page. I'd look at that page. I'd follow all the links from the second page. I'd look at that page. In fact, I would click links and links and links and links and links and links and links until I got out to an enormous part of the web. Would I get to the entire web? Right? I wouldn't get to the entire web. The web is a network. You should be able to figure this out, actually, from what I've already told you earlier in the course. The web is a network. It consists of nodes and links. Each page is a node, and all the links on the page are links. Well, you know that some pages are hubs, right? Some pages are connected to tons and tons of pages. If you find those hub pages, you'll get to a very large portion of the web. But you could also go to a page that is unconnected, has no links to any other page on the web. How would you ever get to that page? If you started at that page, you'd never get anywhere else. If you didn't start to that page, you'd never get to that page because it's not linked to anything else. Right? There's a lot of other reasons why Google can't get to stuff on the web. For example, a lot of pages aren't actually pages. A lot of pages are built automatically from databases. We'll talk about that a little bit later in the course. And if they're built automatically from databases, you can't get to them just by clicking some kind of link. Maybe you had to put in a query, or maybe you had to do something else to display that page, or maybe there is no other way to get to the page except that the server decides that that's the page it's going to produce this time. So there's a lot of content that Google can't get to, but it's actually pretty astounding how much content Google can get to by going out from link to link to link to link to link. And that process of going out from link to link to link to link to link is called spidering, because the web is like a web. And what does a spider do? The spider goes out on all the little strands of the web. You can think of each kind of crossing point as a node, and each strand of silk on that web is a link. And so the spider crawls out on all of those different branches, all of those different links, and eventually finds a very large part of the web. Now, it's not like Google starts at a specific page. Google starts at a lot of pages. In fact, Google will start at as many pages as it can think of that will allow it to spider out, that will allow it to climb out, crawl out to as many different parts of the web as possible. But that's the fundamental idea. That's kind of how it works. It crawls, or it's also called spidering, out to all the different links on the web, starting from a set of nodes. Okay, so you see in this diagram kind of a picture of a web, or excuse me, of a network, and we've seen pictures like this before. This looks an awful lot like the picture, like the social graph picture we saw in the Facebook module. And in this case, it's not people and their connection being that they're friends on Facebook. In this case, they're different websites and web pages, actually different web pages, because in this case, website really isn't even a concept. It's all about web pages. And Google doesn't necessarily know if one page is on site A or a page is on site B. It really only knows about pages. Very, very little that it needs to know really even about the website, just about the web page and all the words that are on that web page. But you can imagine, for example, starting on any one of these dots, that starting from any one of these dots, it's connected to other dots, which are connected to other dots, and before long, if you followed all the links from any dot on this diagram, as long as we don't have something that's disconnected, if it's disconnected, it's not on the net, or it's not in the network, and in this case, everything is connected somehow to everything else, so eventually you'll get to every other node. Now that's kind of cool if you think about it, that if you started any node, you can end up at any other node. Just like if I started from anybody in your social graph, any friend of a friend of a friend of yours, I could eventually get to you, right? That's this idea that everybody's connected, and in fact, if you think hard about it, you're not that distantly connected. You're connected on average to any other person, they say, on the earth by 6 different other people. You go through 6 people and you can get to pretty much any other person on the earth. That's the idea, right? Google, if you want to hear about this, the 6 degrees of separation, and somehow Kevin Bacon got the honor of being the one who exemplifies this 6 degrees of separation, because theoretically he's in the middle of all these networks in Hollywood, right? But that's the idea. You start at any node in a network, and by crawling, by spidering out to all the other links in the network, you can get to every other link. So that's kind of the idea. That's how Google works, by spidering. And so the machine, the program that Google uses to do this is called a spider. Sometimes it's also called a bot, after robot. And that bot it's a bot, I guess, in the sense that it's automatically going to pages as if it was a person. I guess that was the derivation of that term. So either called a spider or a bot. And the spider or the bot crawls the web, going from link to link to link, gathering up all the pages. Every time it gets a page, it dumps that page into the bag with all the other pages. It's going to shake up that bag later on and produce this Mondo index. Okay, got the idea? All right. So, what exactly is getting indexed? Does Google go to each page and grab the words from that page literally, actually, and then search that page? No, that's not what happens. In fact, it's a lot more interesting as far as I'm concerned. Google actually downloads every page and keeps a copy of the page. That's called the Google cache. The word cache means a place. Like you may have heard of geocaching, right? The idea of geocaching is you go someplace like here, the crater of Mount St. Helens, right? And I dig a little hole here and I put some stuff in there. You know, I put a little marker in there or something. And later on you come back and dig it up. That's the idea of a cache. A cache in computer land is a place where you store pages or you store information temporarily. It's not where it came from. It's not where it really lives, but it's your copy of it. It's your copy for whatever uses you're making of it. And in the case of Google, the use that they're making of a cache is to make a copy of every single page on the web. So what I want you to do is do a Google search, and then if you mouse around a little bit, you'll see a little link that says cached page. And I have an example of this here, and it gives you a couple of concepts. One is that the terms that you searched for, in this case I searched for Info 101, they're highlighted. They're literally highlighted in the cached version of the page, which is kind of nice. So if you go to Google and you do a search, and I've done this a bunch of times, I go to Google, I do a search, and I go to the page and I'm like, well, why did it give me this page? This page doesn't seem to have anything to do with the words that I typed. If you go to the cached page, those words will be highlighted and you'll see exactly why it was returned as a result. So that's point A to make. Actually, point A is that Google makes a cache. Google makes a copy of all the pages on the web, and that's what you're searching. That's what's building this index that Google is using to give you search results. That's point A. Point B is that the words that you search for are actually highlighted in that page, and that's a really nice thing. Something that is very useful to you if you ever can't figure out where your search terms are on that particular page. The third thing is, and I've got that circled here and it says 2 weeks out of date, is to know that it takes a while, right? It takes a while for Google to spider out, and it's not going to hit your page every minute. So I made changes to our course website, and they didn't show up for at least 2 weeks on Google, right? So it's not an immediate process. It's not. Now, I don't want to say that every site when it changes takes 2 weeks to update. There's really important sites like, a government site or something like that Google will index pretty constantly and keep it up to date. So my site, unfortunately for this class, is not particularly important to Google, and we'll talk about what it means to be important for Google in a minute, but it takes a good few weeks for it to get around to my site. So my site is really kind of behind the times, and it's not, you won't necessarily find stuff on my site if I just added it to the site yesterday. Okay, so that's the Google cache. Google downloads all the pages, then uses those pages to shake the words out and build the Mondo index and give you back search results. Okay, so let's review a little bit about what this diagram that I've been using says about spidering and what gets spidered. And there's a little bit more detail here. First of all, what I said about all the links and spidering out on the links. There's also you can put a file right on your website called robots.txt, right at the root, right in the beginning of your website. You put this file, Google looks for it, it reads out that file, and it knows a lot better how to index your site, what to leave out, where to go. If there are some pages that are unlinked, it'll find them that way, and so you can actually put a little instruction set to Google right on your website that says how you want it to go about indexing it. There are what's called no-follow links. So right in the link, when you make a link on a web page, you can say, don't follow Google, and Google will say, okay, I don't need to follow that link, and it'll leave that out of the search results. Okay. Oh yeah, you can also ask Google to reindex your site, so you can ping Google, it's called, and if you ping Google, it will know that your site is ready to be reindexed, and I don't know that means that they're going to go like run right out and index your site, but at least it's telling them that, putting you in the front of the queue. And maybe I should do that so that they index our class site a little bit more frequently. Okay, let's see. Oh yeah, so there's also this idea of if there are more links coming into your site, Google's more likely to index it sooner and more regularly. And we'll talk about that a lot more when we talk about PageRank. Okay, so that's the idea of spidering. And let me now kind of summarize where we've been. We got the idea of an index. And if I haven't said it enough times, I'll say it one more time. An index is an alphabetical or numerical list of terms. They could be single words. And in the case of Google, I want you to understand that they are single words, right? They're every single different word. In the case of other indexes, it could be phrases. It could be a 2 or 3 word phrase, arachnids in Africa. And that's a single index term. But in Google, it's all single words because they shake all the words apart. Okay, so that's the idea of an index in general. Google's index, or a full text index as I like to call them, or maybe an inverted index or an inverted file or reverse index, all those different words for the same concept, is that idea of instead of like a book index, in a book index do they take all the words and shake them off the page? No. They go and they choose the most significant words, and some of the words in a book index may not even be in the book. Right? They're just words that are describing the content of the book. But that's not how it works in a full text index, in a Google type index. A Google type index is literally all the words on the page. Now, why wouldn't Google have that same kind of index like we have in the back of a book, where we make up some words that may not even be on the pages of the book? Because it can't. It's just a machine. All it can do is read all the words on the page and shake up that page and turn that page into part of its alphabetical or full text index. So that's the general idea of an index. And the specific idea of the Google index, and there's at least two. I think there's probably likely to be a lot more than two, but I don't know about any other ones besides a title index. That is a full text index of all the words in the titles of all the pages that it indexes, and a content index. That's all the words in the body of the web page that is being indexed. Okay, and then we have this idea of crawling the web. How does Google find all the pages on the web? It finds the pages by spidering out, by starting from as many hub pages in the web network as it can, and spidering out, following all the links out from those pages. And doing that, it's amazing what portion of the web it can get to, but it certainly doesn't get to the entire portion of the web. It doesn't get to the entire web. Okay, that's indexing.